Good morning, everybody, and very welcome at this already third Into Power webinar. Energizing your cable infrastructure, that's the topic of today's very specific but very interesting webinar. I'm Katrien Kriel, and I will be your host today. I work for the POM West-Vlaanderen, which is the regional development agency of the province West-Vlaanderen in Belgium, and I work within the team Blue Energy. So before we really going to start with this webinar, I would like to go through some practical arrangements together with you, and I will share my first slides. As you can see, this webinar will be recorded, so you will be able to see the replay afterwards. Also, please note that this webinar works best when you use Google Chrome. So if you would have any problem, just switch to that browser. And also very important, the question and answers section. In the right side of your screen, you can find a chat function. And via that chat function, you can ask any questions you would like for our experts today. Also note that Celine, who is behind the scene, is our moderator today, and she can also help you with technical questions. Okay, this being said, I just shortly introduced myself. Now I'm also very curious to know who is behind the screen. So I will launch a poll. Give me one moment. And normally when you scroll down on the screen, you should be able to see a question. Which role does your company have within the offshore wind industry? Are you busy with maintenance? You're busy with qualifications of installations? Just let me know. Okay, I can see that several answers are coming in. Also research and development, and also installation. So I think we have a very various public for the moment. Okay, that's also very interesting to know. Thank you very much for your participation on that one. So before we going to listen to our experts today, I would like also give you some more information on cable test facilities. So today we're going to hear the presentation of two types of cabling test facilities, but please note that within the Into Power project, we also made a dedicated webpage on test facilities in the offshore wind sector. So you will find the link to that webpage at the end of the webinar. Also important, why should you go and test a cable test facility? Well, it can be very important to have several testing before you go offshore. And one of the items or one test that can be executed is the testing on material. So, for example, what is the ductility of the cable infrastructure? What are the abrasion reductance of your cable infrastructure? But also, you can test several features under several conditions. For example, what is the influence of temperature on your cable infrastructure? Also, when you decide to go and test in a test facility, it can be very important to have some more information on that test facility, and you can take some elements into account. And I will share my screen again, and you should see the second slide. First of all, we have the fields of operation. So which services can be offered by the test facility and which tests can be executed or which operations can be done? All these elements will be taken into account by our experts today. Thirdly, we have the lead time. So that's the time between the application at the test facility and the moment that the test can really be executed at the test facility. Also, this one is very important for you when you choose your test facility. And thirdly, it's very important for a test facility to know exactly which test you would like to execute. So they should need all information, necessary information from you. Also, this topic will be taken up by our experts today. So for now, I think I have said it all. I will just go live to our first speaker of today, which is Mr. Kevin Weyhaans from Nexans.
Good morning, everybody, and welcome to this webinar. I'm Kevin Weyhaans, and I will present you Ilat. Ilat is an electrical lab which is located at it's located near Aalst, in between Ghent and Brussels, close to the E40. Our main building is in the Industrielaan 12, and our lab is located on the other side of the road on number 17. So as Ilat, we are specialized in the qualification of medium voltage and low high voltage test accessories. Our team consists of 8 experienced people, and we are dedicated to provide reliable and accurate test results represented in well-documented test reports. We are accredited for several specifications according to the ISO 17025 since 2003. Specifications like HD 629, the tests of the IEC 61442, and also the international 6502 are all test specifications we can test under accreditation. Also several tests of the low high voltage IEC 6840 and the low voltage EN 5383 we can test under accreditation. Of course, we have quite some equipment in order to be able to perform these tests, and that goes from lightning impulse testing generator up to 600 kilovolt. The maximum voltage depends on the length of the test loop and the size of the cable. Load cycling testing is actually our aging testing, where we will apply a certain current and voltage according a specific test program. Partial discharge testing we also do usually before and after those aging testing in order to see how the electrical behavior changed during this aging testing. And AC testing can currently be done up to 200 kilovolt. From the spring of next year, we will be able to go up to 350 kilovolt to incorporate the low high voltage part of our tests and investigation possibilities. Temperature-rise is one of the tests which will characterize how your accessory or your cable behaves under load, but also accessories installed, for example, in cabinets, to see what the temperature in those cabinets become under a certain load. Next to that, we have a quite sophisticated heating system where we are able to perform robustness tests. It's actually a type of test that is introduced for joints, and where we will put the accessories in a tube filled with water, and we will systematically cycle and heat up and cool down the water, alternated with some aging of the cable itself. We are able to perform this test up to 3 bars, which is the nominal pressure of tap water here locally. And another test which is becoming more and more popular the past year is actually resistance measurements, mostly then related to screen connection systems. DC testing is also still one of our possibilities, but becomes less and less required as we do not have it anymore in the latest version of the HD 629. Salt fog and humidity testing, it's typically something we do for the terminations, and where we will test how the aging of this product will happen under a salty fog that is spread on those terminations. Okay, it's typically a test that is asked only for the terminations, but I can imagine that there are other items where this behavior needs to be checked. We also do have some long duration test fields, outside test fields, where we can do tests up to 5,000 hours for quite some length of medium voltage cable. Of course, depending on the length of the cable and the size, it will be a limited size. We are not able to perform tests on drums of 100, 200 meters, to be clear. We also provide some support, on-site support, as we became more and more, we got more and more the question to have some heating equipment to be rented. to customers on their premises to test their solutions. It happens more and more that they have to test their systems, their developments, their ideas under a certain load of a cable, and then they need to heat up the cable. And our systems are able to do that. For all the tests we cannot do in-house, we will work together with external parties. Then I'm thinking about short circuit testing, nail testing, screen fault initiation tests, and whatsoever. Then I also prepared a small tour in our lab, which is quite compact, as I was limited by the high loading of our facility and the possibilities of tests I could show based on the customers which are testing. Okay, and I will start it. Okay, sorry, apparently I was muted. So let me summarize. We are active in three topics. Qualification is one of them, which I already explained. According to the specifications you can see below, from medium voltage to low high voltage up to low voltage. Then investigation tests. We participated and performed already contact load testing, where we are actually measuring the mechanical stresses on contacts, for example, in joints when they are installed underground. Screen connection testing and resistance measurement I explained already, and the temperaturized testing of accessories, for example, installed in cabinets, and on the on-site support for heat cycle equipment, depending on your needs. Now, if you are interested in doing a test at our test facility, please send us an email and describe in detail what you want to test and what the limits are, what the specification is that needs to be followed, and what typical test setup you had in mind. If you have questions, you can ask those. We will verify all your requests and come back with a proposal, have a meeting to align on all the details. And once we agreed about a test sequence, we can provide you a quotation. Please note that the lead time of our lab depends on the type of tests you require and depending on the size of the test samples. Not all our test cages have the same capabilities, and we have to plan those in. Typically, around 3 months upfront is the least you need to take into account. So once the test program is confirmed and our, let's go back. The test program is confirmed and we know when the test samples will be received, then we will start performing the test according to the confirmed test slot. And afterwards, we will provide you a test report with all the test results. Hopefully, in between, we do not have to contact you because that means that there are no testing issues with your samples. Okay, that was the presentation of Ilat. If you have questions, please feel free to ask. Thank you for your attention.
Thank you very much, Kevin, for this very interesting presentation. So I've watched the chat function I can see, and I wrote down some questions from the audience. One question was, can Ilat perform qualification tests for cable systems?
Cable systems of the IEC 60840, no, but it's particularly the bending testing which we are not accredited for. But we can do all the other testing like resistance measurement, load cycle testing, partial discharge measurement, impulse testing. All those tests can be done, but we cannot offer you it as a system package test. In the past, we combined it where we got the cables from the moment where they already had their bending test done at another location, and that we performed the dielectrical testing.
Okay, thank you. And the second question from Mike. What is the maximum length of cable that can be used for heat cycles?
Well, there is not one number that we can provide you there. There again, it all depends on your type of cable. Like I said, we are not able to test drums. We are not a facility to test cable drums. We are a facility to test accessories installed on cable loops. Single core we have tested in our indoor lab up to 20 meters more or less. We are now elaborating our test cages with a specialized cage for the low-high voltage testing, where we will be able to go further in length. We have more space, we have a more powerful transformation, voltage transfer for that. But again, we will have to look at that case by case.
Okay, thank you very much, Kevin, for this explanation. So I would suggest now we just switch to our second speaker of today, which is Mr. Simon Cheeseman from Ori Catapult. Let's go live to the UK.
Good morning, everyone, and welcome to the presentation. Katrine, can I run the video first, please? Or can you run the video first for me, please? So what I'd like to do now is share my slides with you. So first of all, an introduction. So there's a nice cheesy picture of me, Simon Cheeseman, and I work for the offshore renewable energy Catapult. My background is electrical electronic engineering, and I worked in a number of sort of public organisations doing large program management. I then, about 10 years ago, came into offshore renewables and started working for an organisation in the UK called the Energy Technologies Institute, which was based at the University of Loughborough. And there we were installing offshore systems, wave and tidal systems. I was the wave and tidal program manager. And we were starting to look at subsea cables even then and trying to understand some of the issues that would be associated with subsea cables. I now work for the Offshore Renewable Energy Catapult. We're a not-for-profit research organisation, UK-based, and I work in our Research and Disruptive Innovation Directorate. So we're looking at sort of future technologies. And I'm responsible for the Catapult's marine energy strategy. So let's have a closer look at the Catapult. Here you can see it here. And so we're a UK organisation. Our headquarters is up in Scotland, in Glasgow. But we've got a test facility down in Blyth on the sort of east coast of the UK that you can see on your screen there. And that was the facility that was shown in the video. Blyth is actually the headquarters for UK national test assets for offshore renewables. And the person who introduced the video was our test director there, Tony Quinn. And so we've also got a number of facilities around the UK. In Hull, we've got an operations and maintenance centre of excellence. We've got an engineering centre in Wales, and then I run the office down in the southwest. So the Catapult's involved in all aspects of offshore renewables for offshore wind, wave and tidal. We typically come in when a technology is around technology readiness level 4, when there's something physical there that we can test and sort of get to know. And really we're helping developers get product to market and also at the same time drive down the cost of offshore renewables. So we get involved in offshore wind. We do blade testing at Blyth. We can test wind turbine blades in excess of 100 meters. We can test the whole wind turbine. We've got the GE Halliard X on our 50 megawatt test rig at the moment. We can test cables. We can test subsea cables. You can see our test rig in the center there. And then we've got our high voltage lab as well, which I'll come on to in a little while with a bit more detail. So just to sort of set the scene for offshore wind, in the UK, it's a growing market as it is elsewhere. We've probably got about 10 gigawatts installed now. Our government's made commitments to have 40 gigawatts in the water by 2030. And in fact, we had the Prime Minister, Boris Johnson, at our Blyth facility last week to look at what we're capable of, because the UK has put offshore wind at the forefront of its energy system to achieve net zero in the future. And we're working with other countries as well to support them with their renewable energy strategies. So we see growth for renewables, and in the future we think, by 2050, we'll see entirely for the UK a sort of nuclear backbone supported by a range of different renewable energy systems. But the problem, as Katrine has already pointed out, is that we've got significant problems, particularly with subsea cables and dynamic cables, those cables that are sort of floating between the seabed and equipment. And we know we've got problems because this is where we're seeing the most of insurance claims at the moment. Probably 80% of claims for offshore activities around cables. A lot of that comes from the actual cable laying process, where it's very easy. These are big, thick cables that are being spilled off a drum off the back of a ship. Very easy to unintentionally get a kink in that cable, perhaps as it lands on the seabed. A lot of problems with subsea connectors as well, either not so much in the manufacturing process, but probably in the connection process when they're spliced together on a ship or or subsea. And then we have a lot of problems, particularly in the North Sea, where we decided to put offshore wind arrays on sandbanks, and we get a lot of scour there. So we end up with cables that should have been buried are exposed, cables that weren't buried are buried, or that they're left hanging. And then there's an issue with the weight there, or there's a temperature issue. And then we're always exposed to the risk of ships inadvertently dragging their anchors. So cable test rigs are very, very important to try and understand and make sure that our cables, one, meet the specifications that are intended to, but in terms of sort of future design and future resilience, are going to meet the conditions that they're going to see submerged in the water. So the video showed you a nice sort of fly through through the facilities. At the top of this slide, you'll see the link to that very same video. So once you get the slide pack that's circulated, you'll have access to that link and you can watch it at your leisure. On the right hand side of this slide are the capabilities for our high voltage lab. The key thing about this is it's a UCAS accredited lab, and we can test full scale cables. We can take cable drums, we can take connectors, we can test either in dry air or submerged in seawater. We've got some testing ongoing at the moment, and we can do both high voltage and low voltage power network capabilities. What you might not have seen on the video is that we've actually now got a grid emulator facility. And so when we're testing wind turbines or tidal turbines, we can actually simulate the grid condition, not only for the UK, but any grid anywhere in the world. And we can test sort of grid connectivity, frequency control, fault ride through, and those sort of features as well. So that's another tool that we've got to help developers make sure that their equipment is ready to operate before it goes offshore. So let's have a closer look at that cable test rig. This was actually built for us in the UK by a company called Osbit, and it enables us to do some significant cable bend testing, particularly for dynamic cables. And what we're also able to do in the laboratory, and you can see that in the couple of little shots on the right hand side, is we're able to take very fine sections off the core of a cable to actually understand what's happening in the cable as well. We're able now to do a fairly accurate prediction of the life that's removed in a subsea cable, because we can actually see the stress cracking, the tree fracture that actually goes through the insulation on a cable, and we're able to determine how much life that cable's got. So these are really important tools and accessories for the sector to allow us to understand what's really happening subsea and to really understand the sort of performance we need from cables in the future. So really, just in summary, just sort of pulling everything together now, we know that offshore wind is actually accelerating, and in the UK, as in other countries, it's a very important part of our requirements to meet our net zero targets. We are seeing problems with subsea cables. We're trying to take steps to deal with that, to understand what those problems are and to try and cure it in the manufacturing phase. But that means we need test centres like ours, like Kevin's, to be able to work with you to make sure that we get these things right. And sort of pre-production testing is absolutely essential. And if you have a cable fault, then that's the sort of thing we want to know about as well. And we can help you diagnose the reason for that fault. So, the same as Kevin, we're always happy to have a chat with you, talk to you about what sort of testing you want, to do specification proving, to do type testing, to do fault finding. So my final slide is the all-important contact details. And that's the one. If you don't remember anything else, remember that one. So there's my final slide. And thank you very much, Katrine, for the opportunity to speak. And I'll be more than happy to take questions. Thank you.
Thank you very much, Simon, for this also very interesting presentation. And indeed, I also have some questions for you from the audience. I wrote down the first question at Catapult Blyth. What supply chain support is available locally?
Okay, so we're very fortunate where we're based in Blyth. We've got we're right on that coast for the North Sea, the southern North Sea, and that's where a lot of installation work is going on for offshore wind. So there's a very strong supply chain up and down that coast. We have sort of crew transfer vessels operating out of the Blythe Harbour. We have cable ships operating out of Blythe Harbour. So we're effectively right in the heart of activity. So we have ship access into our facilities, which bring in cables or bring in very large turbine blades. We have good road infrastructure as well. So logistics isn't a problem for us, and we've got a very healthy supply chain on our doorstep. Because we've been working there for over 10 years now, that supply chain sort of built up around us, so we can support our customers really well.
Okay, thank you. And the second question was from Ben. What will be the next advances in subsea and dynamic cables?
That's a good question, Ben. Yeah, I think, as we move to floating wind, particularly here in the UK, we're looking at floating wind in Scotland, down in the Celtic Sea in the southwest. The focus is really on understanding dynamic cables. They're going to be subjected to much more wave loading, probably installations in much deeper water. There's still a lot we don't really understand about the harmonics and issues around dynamic cables. So actually, it's probably what we call the jewellery that goes around those cables to make sure that they've got the right S configuration, to make sure they land correctly on the seabed, to make sure they don't sort of get all moved around. It's probably all those accessories and making sure those are installed correctly. That is just as important as making sure the cable is fit for purpose.
Okay, and one last question from Kim. What do you see the market looking like for floating wind cables?
Huge, absolutely huge. Our own estimations are that for floating wind in general, the number of platforms, the amount of anchoring materials, anchors and things like that, there probably isn't enough capability in the world at the moment to satisfy that future demand. And it would be the same with cables. I don't think the cable manufacturers at the moment have got sufficient facilities or infrastructure to meet that demand. And I'm just looking at it from a UK perspective. And I think when places like France and other companies sort of get on board, it's going to be huge, absolutely huge. So there'll be no sleep for Kevin and myself.
Okay, thank you very much, Simon, for this explanation also and answer on these questions. So, before we're going to close down this webinar, I would like to invite you for a last poll. And I give you one moment. I will start the poll right now. Normally, when you scroll down again on the screen, you should see the question, which test facility would suit your needs right now? So after hearing the presentations of both experts, is it the first, is it Nexans Ilat? Is it more Catapult's high voltage lab? Or do you say, I need some more information? Of course, that's also a very good answer. And I can see the answers are coming in right now, but I can see that both test facilities are doing very well. And also some persons also need some more information. Of course, that's perfect. You can also ask your questions still in the chat function. Also note that when the webinar closes down, you will also have the possibility still to answer your questions via the chat function. And of course, you can also send a mail to our experts. You will receive the contact details of both of them at the end of the webinar, together with a replay of the webinar. So I think now I have said it all. I would like to thank you very much for your participation today at this webinar. Please note that it's a series of webinars. So the first upcoming webinar will be the one on test facilities on drones in the offshore wind sector, also very important and hot topic today. So it will be on the 3rd of February. So I really hope to see you next year. And for now, I wish you a very pleasant afternoon. Thank you very much.
Thanks, everyone. Thanks for listening.